All right, hello everybody. I think we are about ready to get started here. TJ, throw up the flag if there's any problems with the slides or anything that I'm showing. But first of all, welcome. Thank you so much for taking the time to sit with us today and discuss cellular IoT on the Raspberry Pi platform. So today we're going to break down the usage of low bandwidth cellular on the Pi 4, the Zero, and the tiny Pico microcontroller, all from Raspberry Pi, of course. And oh, happy Pi Day, by the way, as well. But I thought we would start with our mantra here at Blues Wireless, and that is complexity kills. And while I don't really like to read text off of slides for you all, I'm going to read this one. So it is complexity kills. It sucks the life out of developers and makes products difficult to plan, build, and test. Now, this quote is from our founder and CEO, Ray Ozzie. I mentioned this quote because I think it's easy for a lot of us to relate to in our lives as software firmware engineers. And this idea of complexity kills is really in our DNA, right? So the goal is to solve this problem with simplicity, which I think you will see demonstrated throughout our talk today, and which I think we all have experienced using the Raspberry Pi platform. So let me introduce you to the speakers quick. First up is me. My name is Rob Lauer, and I'm Director of Developer Relations here at Blues Wireless. With me today is TJ Van Tol. TJ is our Principal Developer Advocate at Blues. We will be splitting up the demos today to give you a really good overview of using our wireless IoT solutions on a variety of Raspberry Pi hardware. Now, a big part of our jobs at Blues is to create kind of fun, silly, yet somewhat pragmatic tutorials on Hackster. We address some key use cases like a lot of machine learning stuff, asset tracking, remote monitoring, many of them on Raspberry Pi devices as well. So you can see all of our amazing projects at hackster.io/blues-wireless. And some quick logistics before we really get started. If and when you have any questions for the speakers, either TJ and I today, please type those into that Q&A panel you're provided. I think it's like on the right of your GoToWebinar interface. We will be answering questions as they come in as best they can, whoever's not speaking. But please stick around for the end and we'll do some live Q&A with some of the best questions for the entire audience. And likewise, if you have any audio or video issues today, or you just lose connectivity, or you have to leave for some reason, just know we're recording this and we will have a full recording available within a few days, probably 1 or 2 days on YouTube. And we'll send you an email with all that information, along with some additional resources and maybe even a discount code. And speaking of YouTube, just so you know, you can find our channel at bit.ly/blues-YouTube. We do have some really great content up there, all of our past webinars. We got some short form videos there as well that you can browse, some very entertaining bits there. So, okay, let's get to our high level agenda today. First up, I know we have all types of people here from, I know there's some invested Blues customers all the way through to people who have never even heard of us before. So to level set, I want to start with a very high-level holistic overview of wireless IoT from the Blues Wireless perspective. TJ is then going to build on that by showing how to get started with our hardware and services on a Raspberry Pi 4. I'm going to be back then to show off the Zero and the Raspberry Pi Pico in kind of like edge computing situations that tend to be lower power and not necessarily in the range of Wi-Fi. Now, I've said our company name numerous times so far without explaining what we really are. So Blues Wireless is not a cellular service provider. We're not the dudes at the mall like hawking cell phone plans in those kiosks. Rather, we are an IoT company that is focused on making wireless connectivity easier for developers. So we were founded and led by the aforementioned Ray Ozzie, who is the former chief software architect at Microsoft. He kicked off Azure, made his name at Lotus Notes back in the day. So Ray has quite the track record. And at Blues, so we do provide hardware and services that really do back up this message of making wireless IoT, easier for developers and more affordable for all. So this is really our core mission, and I think we demonstrate that in a few key ways. So one is that our focus is really on securing your data from the moment it's acquired by a sensor or whatever on the device, all the way through to landing on your cloud application of choice. All of our hardware solutions are low power out of the box to the tune of about 8 microamps when idle, And when we think about the Raspberry Pi, we don't often think about low power because the full single board computer is generally on the grid. But when you talk about the Zero, when you talk about the Pico, that becomes a lot more interesting. We are also very much a developer focused company. Our developer experience is very much a top priority. And hence you'll see that I think through our elegant and easy to use JSON-based APIs. So to zoom in on the hardware that we provide, the Notecard is really the core the core hardware product that we provide. It is a low power system on module measuring a tiny 30 by 35 millimeters. It does have that M.2 edge connector at the bottom for embedding in your project, and this will make more sense as we go along. There are both cellular and Wi-Fi variants of the Notecard. The cellular version also includes a GPS module as well. And that API I just mentioned, the API, so the way you interact with the Notecard is all JSON. It's all JSON in, JSON out. So there's no, when you're managing the cellular modem, there's no archaic AT commands that you have to send anymore. Blues offers SDKs for Python, which you'll see today, also for Go, Arduino, C, C++. Our community has even put together libraries for .NET, for some proprietary .NET microcontrollers, basically, and Rust as well. There are also Notecard varieties that work globally, so they use the NB-IoT, LTE-M, and or Cat1 cellular standards. Now, to make it easier to use your Notecard when you're prototyping, or really even when you're ready to embed in a more permanent solution, we provide products called note carriers. Now, these are primarily development boards that let you snap in a Notecard and connect it to virtually any scenario you can dream up. So to start with, the Note Carrier AF includes a Feather compatible socket. The A model includes headers that let you hook it up to any microcontroller you want, including the Pico, and you'll see that when I do my demo today. The B is a small form factor note carrier, and these images are not to scale, so this one's actually quite tiny. And most importantly today is the Note Carrier Pi, which is a Pi hat for working with any Raspberry Pi compatible single board computer. So it's got those pass-through headers on the top that just fit right on your 40-pin connector on your Pi 4 and Pi 0. Finally, NoteHub is the Blues Wireless cloud service that receives data as a proxy from the Notecard and in turn securely routes it to your cloud app of choice. And also within NoteHub, you can manage fleets of devices, you can update both host microcontroller and Notecard firmware over the air. This bullet point really also includes file transfers, like if you wanted to remotely update Python scripts on your Pi. I wrote up a project that actually updates a machine learning model on a Raspberry Pi over cellular. And also everything about NoteHub is really all about securely transmitting data both from the Notecard and to your cloud. And I mean secure as in with the cellular Notecard, all the data is transferred off the public internet via private VPN tunnels, and it can optionally be encrypted as well. So there's no certificate management or key rotation required. The cool thing about the Notecard is it knows exactly where to go the moment it is powered on. So speaking of that JSON API, again, everything is JSON in and JSON out. So as an example, if you wanted to get your Notecard's GPS location, you would simply call this request card.location, and it will return in the response the requested location with the latitude and longitude and some other metadata as well. Now, the rest of our API is set up in a very similar way to this. So now, okay, now that you have at least a rough idea of what's going on here, I think to help visualize where the Notecard and NoteHub sit in your IoT solution, let me walk you through this diagram. So you're gonna bring your microcontroller, your single board computer like the Pi, you're gonna use your sensors, your own programming language, really everything that you're already working with. We wanna work, work with your existing workflow, if you will. You're gonna compose packets of JSON data that we call notes. Now these notes are queued on the Notecard. We provide about 2 megs of flash on the Notecard, so you can store quite a bit of data on there. And then at a cadence you specify, these are going to be securely synced either over cellular or Wi-Fi with our cloud service NoteHub. Now, we don't want your data to live on NoteHub. We're not trying to trap you into our service here. we want you to route that data to your cloud app of choice, meaning AWS, Azure, Google Cloud, or even an optimized IoT optimized provider like UbiDots or Losan or DataCake. Now, likewise, it's important to note that communication with the note card is bidirectional. So you can also start on your cloud app and send a JSON-based request to NoteHub using the APIs we provide. NoteHub is going to securely deliver that JSON payload to the note card, to one note card or many note cards, an entire fleet if you want to. The note card will then deliver that back to the host, single board computer or microcontroller. So you can really see how you can handle, in this scenario, like remote control scenarios or updating fleet variables all remotely over cellular or Wi-Fi. But a good question here is to pause and ask why. Like, why would you want to use cellular on a Pi that already has Wi-Fi? Well, the most obvious is if you don't have access to Wi-Fi and therefore have a need for low bandwidth cellular. If you're building a machine learning application and you want that inferencing to happen on the edge and be delivered immediately to the cloud. Security is important too. So cellular, especially on the note card, is far more secure than Wi-Fi. And if you really want the turnkey cloud integration for syncing and routing sensor data. But to even drill into this really more, just to kind of want to make sure we're all totally clear here, it might be interesting to look at like when this makes the most sense. I'm going to repeat myself a little bit here, but if you don't have access to Wi-Fi and therefore have a need for low bandwidth cellular, the note card makes sense. Again, if you're building a machine learning application and want that inferencing to happen on the edge and be delivered immediately to the cloud, again, security, if you want that turnkey cloud integration. But just to be clear, don't think of the note card as a drop-in replacement for the Wi-Fi that you have on the Pi. It's really meant for low bandwidth data transfers. Likewise, if you're looking for really low latency communications, the note card, and really this is cellular in particular, is not that ideal for it right now. And if you're looking for high bandwidth data like video streaming, the note card's not going to be for you. I don't want to turn anybody off here. I just want to be very clear on what we do and don't support. So that's kind of my spiel. I think it'd be great now to look at this from a more hands-on approach and start with the Raspberry Pi 4. And then we'll look at the Zero and the Pico and see how the Raspberry Pi 4 and the Zero use the note carrier Pi hat. And again, we'll get smaller as we look at the Pico with a different note card entirely. So to do that, let me switch presenters over to TJ, and he's going to show the Pi 4 getting started experience.
Yeah, and I went ahead and switched over my camera because I always like to start by, I mean, Rob showed some of the hardware off in slides, but I think it's just helpful to see what they physically look like. And I know some of you also have purchased Raspberry Pi starter kits too, and you have some of this hardware around. So if you want to follow along, that's great as well. If I do go too fast, I'll remind you that this is being recorded and such, so you can always refer back to that later. But I'll start by just showing the note card. So hopefully you can get a sense of how big this is compared to my hand. It's 30 by 35 millimeters. It's a system on module. It's something that you can embed in pretty much any IoT project. But what you'll probably want to use, especially with the Pi, is one of our note carriers. And so this is what the note carrier Pi looks like. You'll see that it accepts a note card here. It has a little connector there for that I2C connection. We also include in our starter kits a Molex antenna, which is what you're seeing here, that's going to help with cellular communication. And I've also got a sensor hooked up here that we're going to be using later in this walkthrough, but we'll return back to that in a minute. You'll see that the Pi hat does have these pass-through headers. So what you'll want to do is just quite simply, and I'll see how good I can align this with a camera, but line up with the headers and attach this. Now we do ship spacers that you can put in here that I'd recommend if you're going to be putting this together for a long period of time. But for today's demo, I'm trying to keep things as simple as possible. So I'm just going to toss it in there and go from there. Now with that, really all you need to do is power things up. So I've got a USB-C cord ready to go for my Pi to give that power. And then the very last thing I'm going to do is the note carrier Pi also has a micro USB connection. Don't know how well you can see it, but right there. So I've also got a cord that I'm going to run to connect that. I got to figure out which way it goes in. There we go. connect to that to my laptop that I'm using to run this presentation, because as you'll see, and now I'm gonna switch around both my camera and my screen. So you should be seeing my screen, and then I'm gonna switch it back so you can see me as well. So that's the hardware setup. That's really all you need. It's a pretty simple setup. You get a note card, you put it in the Pi hat, you attach the Pi hat to the Raspberry Pi 4, and from that point, you're basically good to go from a hardware perspective. When you do have things hooked up, the place to go next would be dev.blues.io. And this is our hub for all things documentation. Blues, you'll find guides and tutorials, reference documentation, API documentation, all that good sort of stuff here. And when you're first getting started, I'd recommend heading to the quick start section of the docs and to the note card and note carrier quick start, because that's going to walk you through the steps that you need to just get up and running with the absolute basics. You can configure this tutorial for the different note carriers that we offer here at Blues, but we're going with Pi today for our Pi Day celebration that we'll be using to go through this. And you'll see the rest of this mostly looks like any other tutorial you'd find for really any sort of technology, software, hardware, et cetera, where it walks you through the steps you need to go to set up, except notice this section over here on the right-hand side of the screen, we have this sort of in-browser integrated terminal. And what's cool about this is that you can actually connect to the note card through what's called the Web Serial API that's built into some browsers like Google Chrome that you can use to actually connect to a note card. And that's actually why I plugged in that micro USB to USB cable to my laptop so that I'm able to make this connection. So at this point, I'm connected to the note card directly in my web browser, which I think is kind of cool. And at this point, I can start communicating with it. So if I scroll down in this quick start, so if you're following this later, there's pictures to help you set up exactly what I just showed earlier for setting everything up. And what I want to do is run my first command. I'll blow this up a little bit. And that's a command called card.version. So I'm going to run this and then talk a little bit about what's happening. So the first thing to notice is, Rob mentioned this in the slides, but the APIs that we have for everything for dealing with a note card are JSON based. So you'll see to send the card.version request, I'm sending a JSON payload that I'm telling it to run a request of card.version. The response is also JSON as well. So the information comes back in a JSON structure. I'm getting some metadata like firmware version and such through it as well. Now, this is the easiest way to get started with the note card, is to just send commands through the browser, because you see I connected and set that up within a matter of seconds. But there are other ways of interfacing with the note card as well. There is the note card CLI, which we have available for Windows, for Mac OS, and for Linux. You can also use that to connect to a note card and to send requests. You can use this approach if you want to go through all of this setup and do everything directly on the Pi itself. Basically, what you'll need to do is install the note card CLI on the Pi, and then there's APIs for interacting, sending requests like this through that approach. And you can see, follow these links from dev.blues if you're interested in trying that out. Because for today, I'm going to stick with the browser. The other thing you can do is we have SDKs that are available for interfacing with a note card as well. So things like C++, Arduino, Python, Go, and such, you can use those for sending these commands as well. And later on here in a few minutes, I'm going to show, we're actually going to write a quick Python script where we're going to automate some of these requests as well. So lots of different ways for interacting with a note card depending on your situation. But the easiest, and what I'd start with like your 101, is just doing it through the browser, because it's easy. It's also really cool and fun to do. I'm still amazed that this sort of thing is possible. So it's a lot of fun to use as well. So that's the hardware setup. We sent our first command. Chances are, though, you're interested in the note card because you want to get more than the version number. So usually the next logical thing you want to do is get some sort of data. Maybe that's like sensor data, location data, motion data, something, and send that up from your local system, from your local Pi, up into the cloud where you can do something with that. And with a note card, your next step to setting that up is to set up NoteHub. Now, NoteHub, as Rod discussed, is sort of our thin cloud backend that makes it really easy to integrate with the note card, and then to take that data and send it basically wherever you want that data to live. Now, the first time you go to NoteHub, notehub.io, you will create an account. I've already created one to save us a little bit of time. and then you'll need to create a project. So a project can be whatever. I'm going to keep things really basic and just call mine getting started. A project is nothing more than a logical grouping of really data and devices that you want to store, that you want to associate with a note card. And when I create this, it's going to give me an identifier that identifies the project I just created, which I'm going to copy, because the next thing I need to do, if I go back into the quick start, which again, if you're trying to follow along and I'm going a little too fast, keep in mind a lot of the steps I'm showing here are just going through the quick start, and you can look back onto this later, because the next command I need to run is the hub.set command. So for this, I'm basically saying which Note Hub project should I associate with this note card. So I've got a placeholder in here, and I need to take that value I just copied for this new getting started project. I ran and run that to essentially create that connection. Now there is one additional step that I need to run. I need to run this hub.sync command as well. The reason for that is we designed the note card to be very low power friendly by default, to the tune of 8 microamps while this thing is idle. And we do that because a lot of people use note cards for a wide variety of things, and lots of those are in situations where battery is extremely important. Think about like a location tracker that you're shipping around. You have to use battery power for that sort of thing, and it might be quite limited. And things like initializing a cellular connection using a cellular modem does use up a decent amount of battery. So the note card does try to be a little bit conservative in how often it makes that connection. And a sync is the explicit way you can tell the note card, hey, go ahead and do this, take any changes that have made locally, like such as running a hub.set request, and go ahead and send that up. Now I will note that the note card is incredibly configurable. So if you do know you're going to be on a hard power connection the entire time, you could set various flags to make things sync essentially immediately, so you can get as low latency as you can with a cellular connection. But the defaults are very battery friendly, so that's why I'm running this hub.sync. All right, and since I did run the hub.sync, I should be able to come back here and refresh and see my device. There it is, last seen just a minute ago, that I have up here. And so I now established the connection between the Raspberry Pi that's sitting on my desk and the note card I have running in here, and this backend that came into Note Hub. And Rob, this might be a decent spot to stop. I don't know if I'm missing anything or if we had any questions that have come in. And if not, I'd encourage people to ask some as we're going.
No, a bunch of good questions. I was going to say too, one thing you could show off is we have a little hidden shortcut in the terminal as well to turn on watch mode. It's just a W. It's not documented, so I can't guarantee it's always going to be there. But it's kind of handy to use, like if you run another hub.sync TJ, you can kind of get a high level overview of what's going on with the note card in the background. But yeah, I can cover a couple of the questions we've had so far. Question about MicroPython and CircuitPython support. And yeah, this is really valid. MicroPython, especially when you start talking about microcontrollers like the Pico. And I will be covering that a little bit. I mean, I'll be writing, technically, I guess, writing MicroPython on the Pico, even though it's, I think, 100% exactly the same as Python that you would write anywhere else. Another question about, external SIMs. So in case we weren't super clear about this, there is an embedded SIM on the note card. So it's all burned in when the device is manufactured. But if you're in a country that does not have one of our first class network partners support, and that tends to be like either India or China, or two slightly big countries that don't have support, we do have on every note carrier the opportunity to slot in your own SIM card. For instance, I've done this before with the Twilio Super SIM when I sent an asset tracker to India and beyond, and it worked great. So just know that there are options there for if your country is not explicitly supported.
Cool. Yeah, good questions. Make sure to keep them coming in as we go through this. Was there one more you were going to cover too?
There's so many more coming in.
Let's pick one more, and then we'll keep the rest for the next stop.
Yeah. this is an interesting one. I've not heard anybody ask this before, but it's a valid question. Can you link to more than one project in NoteHub at the same time? Um, so there's with Notecard and NoteHub, there are, a million different ways to approach this problem. So in this person's example, they say like maybe a microcontroller would have a pressure sensor and temperature sensor, but a group of users only care about pressure but not temperature. So to answer your question explicitly, yeah, you could have more than one project associated, but you'd have to programmatically switch that hub.set request, which feels like a little bit of a hack. There's also on the back end different ways you can do this. TJ is going to show this off, and I'll do a little demo of it as well. But really, probably the most important feature in NoteHub is the ability to route data, and you can route different chunks of data to different people, different clouds, or whatever you want to do. So yeah, there's definitely ways to accomplish that.
Cool.
All right, I'll stop bugging you, TJ.
Oh, no, that's cool. Those are good questions. And just to where we wrapped up is we had sent data from our Pi from our Notecard up to NoteHub. I did want to quickly show that the communication is bi-directional. Rob quickly showed this in slides, but I just wanted to show a concrete example. So the previous time I took some, actually, we got to show data one way up first because all we did was the sync. I'm getting ahead of myself, Rob. You're throwing me off.
And I can throw you off even more. I just realized that I don't think GoToWebinar, when it does its recording, I don't think it records our video. So if you want to, when you get a chance, just swap video and show off your setup like you did.
Oh,
or did you show that on your main screen?
I showed it on the video. I don't know. I'll show it again on the
Okay.
camera when I'm done.
Just for our folks who are watching this later. Anyway, sorry.
Yep. No, we're good. So the next thing I want to do is actually send some data. We're actually going to show both directions, showing data in heading, going from the Notecard to NoteHub and in the opposite direction. And so to send data up, I use another request called note.add. And the body can be any arbitrary sort of data payload. And we're going to start with some hard-coded data, and we're going to switch that over to some live data here in just a minute. But to start, I want to send some hard-coded data, and I'm going to run another hub.sync because, again, just by adding that data doesn't mean it's automatically going to appear in NoteHub. So I have hard-coded data. I'm going to sync it. If I go back to NoteHub, if I go to the events section, you essentially see a running log of all different data, all different activity that's happening with your note card. And you'll see because I ran that sync, I see my hard-coded data sort of made a pass-through here into NoteHub. Now, I did want to show that it's bi-directional. So if I go back to my devices list, I can add a note. Remember, the add note is the same command we ran over here. But in this case, I'm going to run it in what we call a QI request, which is a weird acronym. You kind of have to read it backwards. IQ inbound queue, inbound incoming to the note card. Don't worry too much about the sort of conventions, the abbreviations. What it really means is just I can send data both ways. So in this case, I can say I want to send this JSON payload from my cloud into the note card. And so on the note card, if I again run a hub.sync and find the right button in my keyboard.
And I apologize if you already mentioned this, TJ, but what TJ just showed is also possible through the NoteHub APIs. So you can do this programmatically and not through the UI.
Yep. The UI is good for testing, but like in a real scenario, you might have your own like web app or mobile app that's you're using as like a remote controller of your device. You might just be changing settings on the fly. There's lots of different ways or lots of different things you can do when you can communicate in both directions. I just want to show there's a separate request called file.changes. That's a way of getting any changes that have came from NoteHub. So in this case, I'm getting a data QI request. That's the one I just queued up. And there's a separate request called note.get that I can use to get that data. And I can get the values that I hard-coded up in NoteHub. But again, I really just wanted to show you that this is possible. The actual use cases, like remote control is one big one. Rob and I have a coworker that built a robot that you could control. You could essentially send commands, and it used this sort of approach to send commands down to the robot to have it do things like move its arms and whatnot. You can change settings on the fly. Rob mentioned earlier that he's built a location tracker and sent it around the world. He was able to change like the settings and some of the configuration as it was quite literally traveling, which is kind of slick that you can do. That's one of the cool things that's enabled about using cellular as a backing for this is you can put this, put your Pi, put your note card out quite literally anywhere that has cellular connection and sort of interact with it in multiple ways, which is kind of cool. All right, so with that, we now have our note card, our Pi set up. We're sending some data. The next thing I want to show, so when you get to this point, I think the next logical thing to do, we talked about the quick start. We essentially showed very quickly the steps that go into that. If you go to this guides and tutorials section, the next two things we recommend completing is our sensor tutorial and then our routing tutorial. So the sensor tutorial will help you kind of take those hard-coded values and switch over to some more real values that you're actually collecting and sending up to NoteHub. And I'm not going to go through every step of this, but I will show you my sort of development workflow and how I approach that. And so I'm going to bring up Visual Studio Code. And for me personally, the workflow I like to use for interfacing with my Pi is using Visual Studio Code's remote, I think it's remote, let me get the exact name for you, the remote development extension for Visual Studio Code. I think it's a really, really awesome way of providing, well, in that case, I use it to SSH into my Pi. And then I have both a terminal as well as a code editor that I can use on my Pi that's, well, it's just sitting here. I can remote into it for my main machine. All the steps I'm showing, if you like to just work on your Pi directly, all of these steps that I'm going to be showing are going to continue to work exactly the same. So I'm going to open up a little project, a little script that I started called sensors.py. So I mentioned earlier that I had a sensor hooked up to my Pi. It's very specifically a BME 280, which is a really common temperature, humidity, air pressure sensor. And this script is a script that I basically just found on the internet and copied and pasted it. So if you looked up like the BME 280's documentation, it's going to tell you to use this syntax to do the connection. And then here's how you get your data. And then if you run this thing, just Python 3 sensors, I'm going to just be spitting out the humidity, pressure, and temperature readings every 15 seconds to my console. Now, I like showing this example because I think this is a pretty common scenario where the note card can be quite useful. So you have some sort of sensor, some sort of data, and you want to take that data and actually get it from your Pi into a cloud backend where you could do something more interesting with it. So I thought I'd show how to add the note card into a situation like this. And it's really just a handful of steps. The first thing you need to do is install our SDK. So it's going to be pip3 install, and this will be in the sensor tutorial, so don't worry about necessarily remembering this or anything. But you need to install 2 dependencies. So NotePython, which is our API, our SDK for interacting with the note card through Python, and Python Periphery, which is a library that just makes I/O communication through a lot of different protocols really simple. And I'll show where we're going to be using that. Now, once you have those 2 things installed, the first thing you need to do is import them. So I'm importing the note card. I'm importing Periphery because we're going to be connecting to actually interface with the note card through what's known as I2C. You don't need to know all the details about that. That's just the sort of implementation details of how you access the note card. Once I have the imports done, the next thing you need to do is, again, this is pretty code that you can find on our sensor tutorial that's pretty easy to copy and paste, but just to actually perform the I2C connection to get access to the note card, get this object here that we can start to do interesting things with it. And then from this point, that's really the entirety of the setup. From there, you're just going to run the same sort of commands that we were just running in the browser. So I'm going to take and set up a connection here. Well, I'm going to build up a Python dictionary object that's going to connect to a NoteHub project. So I have a separate one set up for this. And then there is an API that's part of NotePython for actually sending transactions through the card, essentially sending these requests up to NoteHub. So I'm going to run a hub.set. And then down here, when I collect this weather data, I'm going to add one more step that actually sends that data using that note.add command, the very same one that we ran in the browser, but just doing it through this Python script And for the body, instead of using hard-coded data, I'm actually going to take the live data from my sensor and push it up as well. So I'll save this and run this. And I think, indentation matters in Python, so I got to fix that. So I'll run that. And then every 15 seconds, I'm going to take readings. I'm going to send this up to NoteHub. So back in NoteHub, I used a separate project for this. I used a project called Weather. So I'm going to head into that. I'm going to look at my events list. And what I should see is the newer data coming in. I think it's, let's see if it's, one of the things you can tell by when NoteHub runs, part of the reason I'm printing out the results of this is this total. It's basically telling me how many notes the note card has queued up and is waiting to send to NoteHub. So this is the one thing about using a cellular connection is, and this is why Rob had on this, the note card isn't a solution for things where you need completely instantaneous bandwidth, since you are working over a cellular connection, and it could sometimes take time to initialize the cellular modem and send your data over. So in this case, it's collecting the readings, but it hasn't actually synced them to NoteHub quite yet. And once we see that total goes down, it does.
I was going to say we've all been very spoiled by our smartphones and not appreciating what is actually going on behind the scenes, because cellular is very, very tricky. And especially when you're using protocols like LTE-M and NB-IoT, these are very, these are not the forgotten portions of LTE, but they are, I don't know, deprioritized in many ways.
Yeah, well, and it's cool too. Apparently I screwed something up. We'll see if it actually came through. But the cool thing to remember is that this is all happening over cellular. It's sometimes easy to forget that this Pi could be sitting, out in a field somewhere, and it would continue to operate correctly. Although I might have typoed something, Rob, in my demo, but we'll see.
Yeah, are you, can you scroll up in your code? Yeah, that looks good.
I don't know. I'll probably look back at this later and find out I put in the wrong snippet into the wrong place. But I can still show, you can pretend that this data came through through the magic of demos. But the data is getting queued up here, but I do have some readings from earlier when I was testing this out that appear down here, because the last thing I want to show, and we'll see, maybe that'll fix itself. We'll let it run in the background. But the last thing I want to show is how to route your data. So once you have your data in NoteHub here, the real question is then how do you take the data and do something interesting with it? And routes, and the routing tutorial will help walk you through this, can help you provide a number of different places that you can send your data. And that can be a big cloud like AWS or Azure or Google Cloud. It can be something like MQTT. It can be an IoT platform like DataCake or UbiDots. Or you can just say, whenever I get an event in NoteHub, just fire it to some HTTP endpoint that I have set up to accept and do something interesting with that data. The routing tutorial will help you with the details on that, so I'm not going to go over everything, but I just want to quickly show that I do have a integration of route setup for UbiDots, which is an IoT platform that helps you build visualizations around your data. So let's see if we have, oh, it did fix itself. Okay. I don't know what's going on, but we should have like 12 readings queued up, so we should have a bunch of stuff that shows up here. Yeah, there we go. So see, it didn't lose any of those readings. It just sort of queued them up. So you'll see actually too, they should be about 15 seconds apart when they happened and they came through. And then because these events are all being routed, I can head to UbiDots. And if I get data for the last hour, you're now essentially seeing live data points coming from my office and feeding into this dashboard. And it's real time too. I can refresh this and see updated data as well. And I like showing this because I think at this point, this is kind of the full path. When you actually get a starter kit, a Raspberry Pi starter kit from us, that is the path I would recommend. Going through the quick start so you can see how to set up the communication in both directions, and then going through the guides both for collecting sensor data, and the sensor tutorial too is something you can configure based off your hardware, based off whatever things that you have to send data up, and then routing it to whatever end destination you have in mind for your data, whether that is building something like the dashboard I showed, or maybe like your own database or whatever sort of thing that you have in mind. So that's the full flow. I'm happy that that worked, Rob. I don't know what I did at first, but it looks like data's flowing through fine now.
Magic of cellular.
Yeah, and I'll go back to showing because you had asked. Now that that's working.
Oh, I just made myself presenter here. Let me.
Oh, you're ruining it, Rob. You
Oh,
wanted me
you're
to
good
do
here.
this, so this is the Pi, just in case it didn't come through on the video earlier. You can see, depending on how good I can get it to focus, how it's just a Pi hat for the Pi, the no carry Pi plugs in there, and then the note card slots in through that M2 edge connector in there as well.
Cool. Thank you, TJ. So, are you seeing my
I do,
slide
yep.
again? Excellent. So, I did want to mention a couple quick things about the Raspberry Pi hat that TJ just showed off. First of all, it is of course compatible with the Raspberry Pi 4 and the 0, 1, and 2. I didn't say the Raspberry Pi 2 and 3 because some of those models include a current limiting fuse that can power cycle the device when the no card's modem is on and transmitting. Your mileage may very much vary here, because I've heard of some folks who've had no problem at all. But just so you know, we recommend the 4 or the 0s. There are also some dip switches on the back of the hat, and those enable usage of an active GPS antenna and serial access as well. And I think, I mentioned this before, but there's a external SIM slot there if the embedded eSIM on the no card isn't supported in your country. And there's a Grove port on there for connecting to external peripherals. And again, finally, that 40-pin hat is stackable, so you can add other Pi hats as needed. So I did want to shift focus a little bit into the Raspberry Pi Zero. This is easily my favorite tiny little Linux single board computer. And I'm going to be honest with you, using the Zero with the no card is just not really any different than what TJ showed with the full-size Raspberry Pi. Since the Zero does have that 40-pin connector, you just slot the hat on top of it. But this does make the Zero a great option for these lower power edge computing scenarios. So I did want to walk you through a quick story with how I used the Zero with my home's hot water boiler system. So I decided to build a project that used a Zero with the note card and built out a machine learning solution that used a thermal camera to perform anomaly detection on thermal images. So to do this, I wired up my Zero with an MLX 9640 thermal camera. It produces these really tiny but still pretty cool looking, no pun intended, at 32 by 24 resolution thermal images. And I wrote a really simple Python script on the Zero to take those thermal images every, I think it was 5 or 10 minutes, to see what my heating system looked like under various conditions. And I was able to classify 3 really high level types of images. So cold, the system is off. Warm, it's either heating up or cooling down, and hot, meaning it's actively running. Now, since my system wasn't acting up in any anomalous way, thankfully, I did have to create some anomalies of my own, which I did with a little help here from Photoshop. But this really gave me the start of an image classification ML model. And I built this out with Edge Impulse. Now, I don't have time to dive into Edge Impulse here, but if you're really looking for, frankly, what I think is the easiest way to build a variety of machine learning models and deploy them to numerous types of MCUs or Raspberry Pis, Edge Impulse really is the way to go there. But I ended up, pulling in all these images to properly create an ML model and classify the images as cold, warm, hot, or anomalous. I think I started with like 120 images, which gave me this fancy looking GIF here. And I got this, ML model built out of it. So I used the note card to actively relay this data, these inferences to the cloud. In this case, similar to TJ, I built a super simple UbiDots dashboard. But this is really a great example of the opportunity of machine learning. And that is, instead of uploading all of your accumulated data to the cloud for processing, which can have, of course, logistical and privacy concerns, you're creating these inferences locally and just sending what you need, right? The final result to the cloud. I could have easily added on an alerting system here as well with NodeHub and Twilio to automatically send me SMS alerts when anomalies were detected. A lot of great use cases here. You're not meant to read this code, but I did want to demonstrate this was all pretty much accomplished with just a few lines of Python code effectively. This is not the full script, but it's actually pretty close. This is, again, one of the many tutorials we have on Hackster, but I just wanted to really quickly show this off as an example of where the 0 can fit into a scenario where, cellular and machine learning overlap, for example. And that brings us to the Pico. Now, the Pico is a dramatic shift from what we're used to with the Raspberry Pi 4 and 0. The Pico, if you're not familiar with it, it is a tiny little microcontroller, meaning it doesn't run the full Raspbian OS, but it does allow for way more, low power, low cost, really targeted applications than you could ever imagine performing on the 4 or the 0. And drilling in on the Pico just a little bit, as mentioned, it is not a single board computer that runs Linux. It's a very low cost microcontroller. I think about $4 or $5 US last I checked. It is built around the new RP2040 microcontroller chip developed in-house by the folks at Raspberry Pi. It has a fair variety of I/O options, lots of GPIO, I2C, UART SPI, and so on. It also has a programmable I/O, PIO, which these are effectively like state machines for custom peripheral support. It's really pretty cool. Outside of the scope of what we're going to talk about today, but I did write about it on the Blues Wireless blog if you are curious. Again, a pretty flexible board that supports both MicroPython and C or C++ development. So with that, I would like to show a demo of how this Pico can be used with a note card. And let me stop showing this and show off my, let's see, I want to show Thani, but also show my, I love GoToWebinar. Got to go back to preferences to start showing my.
All the menus. Thani
Yes.
looks good. We see your Python code.
And there we go. I hope.
Yeah, we see your setup as well.
So I'm not here to insult anybody's intelligence here in any way, but I do want to kind of walk through the wiring diagram or wiring of what's going on here with the Pico and the note card and note carrier. So here, of course, is my Pico, and it is wired up, as you can probably tell, to 3 different LEDs here. These lights will make more sense when I show you the code. They all have a common ground with the Pico through the little yellow cables here and then the orange one here. The Pico itself is wired to note carrier A. The note carrier A has a black note card on it, which, if you remember from the slides, is a Wi-Fi note card. I just wanted to show off this Wi-Fi note card, frankly, just to do it, but also to demonstrate how the APIs we provide are perfectly matched between cellular and Wi-Fi. So you can actually have a mixed deployment between cellular and Wi-Fi in the same project without any code changes. And those are connected. We got power and ground here, and then it's connecting over I2C. So I've got the SDA and SCL on the note carrier hooked up to the equivalent pins on the Pico. And I keep moving this around, but I think you can still see it there. So pretty simple wiring here. So let me plug this in with my micro USB cable, and we'll see the note card boot up there. And then back in Thani, I'm going to restart here and make sure this one is actually open. It is. And again, this example I'm going to show you is embarrassingly similar to what TJ just showed off. Why can't I resize this window? That's interesting. Okay. But I did want to just walk through really quickly here what's going on and what these LEDs are all about. One thing I wanted to mention is, oh, it's interesting. Now I can't actually click on anything in here. Good old Thani. I am going to reestablish a connection here. You know what? I'm going to quit Thani.
Yeah, I mean, visually it came through fine. We were able to see the code okay, but I'm guessing the UI seized up a bit.
Yeah. All right.
It's one thing about working with some of these microcontrollers. Actually, Thani is like the good example. So it can get even crazier.
Yeah. Thani's really nice for MicroPython development, I gotta say, generally, when it doesn't freeze up. So basically, I'm performing a variety of initialization code here that we don't really need to dive into, but you can see that the LEDs are connected through the GPIO 13, 14, and 15, the red, green, and blue. There's an onboard LED as well on the Pico itself. That's pin 25. Like TJ was showing, I'm simply associating this note card with the this project I set up in NodeHub. And again, like TJ showed, I'm sending the hub.set JSON request with that product UID and setting it into continuous mode. I've got 3 different quick methods here. One turns all the LEDs off, one turns them on, and one flashes them, right? Pretty dead simple. And I confess that I actually stole most of this code from Jeff Geerling. He wrote a really nice little Pico project on Hackster. He actually developed this really simple board to show off the temperature, show off LEDs for a nursery. He had a baby not too long ago. And so green is obviously like a comfortable temperature. Red is too hot and blue is too cold. So that's all that's going on here. We're just looking at the temperature onboard, the onboard sensor of the Pico, and lighting up the appropriate LED based on that. And again, similar to what TJ just showed, I'm sending a temperature data up to the cloud. I'm sending it in this temp.qo note file. And again, remember that one note file can store multiple notes. So if you're in more of an offline scenario, you might want to queue up 10, 20, 30, 40, 50 notes in a single note file and then sync those all to the cloud later on. And I'm going to sleep for 20 seconds and perform that loop forever and ever and ever. So let's just run this and we'll see all the debugging output here. So you see the temperature comes through in Celsius and Fahrenheit. We've got our note.add request with that temperature, and we're syncing that data immediately. You'll see red, it's way too hot in here for a baby, technically speaking.
What are you doing in your basement, Rob? That's a warm basement.
I think it'd be way colder. So good, my data is being gathered, and as TJ was showing off, that total 1 means there's 1 note ready to be queued, and it looks like my data is going through to NodeHub immediately. So let's just prove that out by reloading my NodeHub project here. And of course, we're seeing that data, we're seeing the device come through here, and we're seeing those events right here. I can drill into this events, and again, this is nothing that you haven't already seen from TJ, but just to prove out that this data is coming through. Finally, I did want to show off the creation of a very simple route, and what I want to do is slightly different than what TJ showed off. I want to use really my favorite testing site is webhook.site. This makes it just dead simple to test out these routes. So if you go to webhook.site, you just get a unique URL that you can use. I can copy this in. I'm going to create a route. It's going to be one of our general HTTP request response routes. This is as simple as it gets. I'm just going to call this Pico route. I'm pasting in that URL from webhook.site. There's a lot more I could do in here in terms of like adding headers for authentication purposes. Maybe you can choose which note files you actually want to send. You probably maybe don't want to send all of your session metadata. You just want the data itself. You can also transform your data with JSON-ATA, which can be really, really powerful to kind of optimize that payload. But I'm just going to keep the defaults here and create a new route. It's been created. I can hop over to webhook.site, and there, some data just came through, right? So it shows you really how easy this can really be to get data, obviously in my case over Wi-Fi, but I could swap in a cellular note card and do exactly the same thing, really just in a matter of minutes. So with that, let me pop back over to our quick recap here.
Yeah, and what I like about using the Pico too is it really does make these sort of low power situations totally possible. Like you could run that sort of thing off a battery 100%.
But yeah, so we just wanted to really thank everyone for attending here. Before we get to the Q&A, make sure you visit dev.blues.io for all these technical resources like, our quick starts, our API documentation, and some of the tutorials. And also, even more importantly, just for being here today, you can take 15% off your first Raspberry Pi starter kit at bit.ly/PiDay15. And with that, I think we can safely jump into some questions here. I know we're running up against the top of the hour, but we got so many questions here, and I don't even know where to begin. Let's see.
Well, we should say if we don't get to your question, because we want to respect your time and not take all day as well, the Blues forum, which you can get to by just going to the support link and dev.blues.io, is a great place to ask any questions that you have. Rob and I both lurk there, as does a lot of other people at Blues. So if we don't get to yours, sorry, we're going to do the best that we can, but that's a great place to ask if you have any questions about literally anything.
So many good questions in here. I'm not afraid of any like negative questions either. Like, so as an example of a quote unquote negative question, somebody asked about the accelerometer on the note card. So we do have an accelerometer on the note card, which is really great because it allows us to dynamically turn on or off like the GPS module, for instance, if there's movement that's been detected. But somebody's asking, like, if there's an accelerometer, why is it not exposed? So we do not expose the accelerometer data through the API. It is on our roadmap, but it is surprisingly complicated to do so for reasons that I cannot remember. But anyway, just wanted to put that out there that there is an accelerometer, but it is not exposed through the API. Question came in about how long it takes to get a GPS position fix in clear sky. This, GPS is kind of the bane of my existence because it really depends on so many things. Like, are there any obstructions? Is it cloudy and blah, blah, blah? What kind of antenna are you using? But in really ideal scenarios, you should get a connection in less than a minute. It can take longer, again, depending where you are in the world almost and how good your antenna is. A question came in about how much data can you send to the note card at a time? This is a really valid question because, like I mentioned in the beginning of the slides, that we do support file transfers with the note card. And really our general rule of thumb is that you can send about 8 kilobytes at a time over even kind of the worst cellular connection. And to accommodate file transfers, which obviously are probably going to be a lot larger than that, in the API, we actually bake in the ability to chunk up the data into like 8 kilobyte chunks or whatever you specify, and send those to the cloud one at a time, and then reassemble that file on the cloud. So all the capabilities are built in, but we had to make some accommodations for how cellular may change.
Yeah, and I'd also say, like, that sort of thing is possible, but keep in mind that the note card isn't intended for any sort of high bandwidth situation. So if you are talking about small files are fine. We have people that do things like send images over using the note card, but any sort of higher bandwidth situation, it's going to be rough because remember, this is a cellular connection we're talking about. So just something to keep in mind.
Good question came in about powering the Pi for cellular access. And yeah, I mean, I've had luck with, for example, the Pico here. We do have a LiPo connector. So if you have any kind of lithium polymer battery, you can connect that to the note carrier and it'll power the Pi, or power the Pico rather. And you could connect, I mean, you don't need much, frankly. Any LiPo battery, or in the case of like a full-size Raspberry Pi or Zero, I've even used like a big USB-C power bank for those if you really want to go the overkill route, but there's a lot of options there. Somebody asked about the code difference between sending data via Wi-Fi and cellular. It is one of the beauties of the Wi-Fi note card is that there are no code differences. It's the same note.add syntax. There are Wi-Fi specific APIs for setting up that connection to your Wi-Fi router, but that's really about it.
Yeah, really, for the Wi-Fi note card, you just run a card.wifi request and you provide like your SSID and password, and then from there, it's quite literally identical from everything else.
Another question about power. So for the Note Carrier A, is there a specific brand of solar panel and battery recommendation? Solar panel, well, there's so many options out there. I have one in particular that's stuffed somewhere that worked fine. Battery, again, any LiPo battery should work. I always recommend people go to Adafruit.com to buy their LiPo batteries. They seem to have the best quality ones. Any plans about offering a LoRa note card? No, but we do have a LoRa product that or a reference design, I should say, that's coming out shortly called the Sparrow. Definitely outside of the scope of what we're going to talk about today, but the Sparrow effectively communicates is a LoRa gateway. So sorry, not a LoRa gateway. It acts as a gateway to LoRa sensor nodes, and then it uses either a Wi-Fi or cellular note card to then backhaul that data, relay that data to the cloud. Kind of a deep conversation to get into at the very end here, but we do have that option coming out soon. And I know we're over time, so I appreciate y'all hanging out here. Let's see if there's one more question in here. Let's see. Oh boy, there's just so many to look through here.
Pick the best one.
I know. Let's see. Okay, one just came in. I'm going to do this one. So Wi-Fi will fail over to cellular and vice versa. So know that there are the note cards. There are two separate note cards. So the one you see here, I think I'm still showing this camera, is the Wi-Fi note card. That's Wi-Fi only. There is not a note card that has cellular and Wi-Fi in one. You'd have to develop, your own PCB effectively to include both Wi-Fi and cellular, and then you get kind of fancy with doing failover yourself. But it's a very good idea. And I think with that, we will shut things down here. Thank you again, everyone, for attending. Hit us up. You can follow us on Twitter or reply to the email that we'll send out shortly with the follow-up resources.
Yeah, and I'll remind people one last time, it's discuss.blues.io is our forum. So if we didn't get to your questions, I'm sorry, but that's the best place to follow up, and we can continue the conversation there.
Excellent. All right. Thank you, everyone.
See everybody. Thanks for coming. Happy